review if you needed help with Module 4 before you took the Module 4 test. So, what conditions are necessary to perform a confidence interval for proportions? And this is true also if you're doing hypothesis testing. What conditions are necessary? Well, the first condition is it has to be a random sample. That has to be true. Now, the second condition is we either need to be normal or the sample size needs to be big enough. And for proportions, that's n times p is greater than or equal to 10. And n times 1 minus p is greater than or equal to 10. And my marker's dying. Okay. What about for means? Well, for a mean, it still has to be a random sample. And if we know it's normal, then wonderful, great, everything's great. Or the sample size has to be large enough, which for means, that means n has to be greater than 30. Many people sleep in on the weekends to make up for short nights during the work week. A random sample, check, of 40 adults found that the mean sleep time, so I see that we're using the word mean, and 40 adults, that's large enough. Great. The mean sleep time for 40 adults, okay, so n is 40. The mean sleep time for those 40 adults is 7.6. That means that's coming from the sample, so x bar is 7.6. With a sample standard deviation of 1.2. Construct a 95% confidence interval. Okay, so the population standard deviation is unknown. So we can't use a z interval. We have to use t. So we have to use t-scores. So on the ti, that means we're going to use a t interval. Or if you're using the online calculators, you're going to be selecting the t selections. So I'll go to stat tests. We can't use a z interval because we don't know the population standard deviation. We're going to go to t interval. And we're going to type in our statistics. X bar, that's the sample mean. SX, that's the sample standard deviation. N is the sample size, and confidence level is 95, so 0.95 is correct. Calculate. And so it gives me this range of 7.2162, 7.9838. So, how do we interpret this interval? Well, I am, or we are, 95% confident that the true mean sleep time is between, we can round, 7.2 and I would round up to 8 hours. Scores of males on the 1974 Mathematical Scholastic Aptitude Test, the MSAT, were normally distributed, awesome, with a mean of 500 and a standard deviation of 100. Suppose we sample 50 and the mean score is 450. So this is telling me stuff about the population here, that the whole population had this information. Then it's telling me about a sample here. So the sample was 50, which, by the way, that's big enough even on its own, even if we didn't know that we were normally distributed. And X bar is 450. This is coming from the population. So this is a population standard deviation. So that symbol is 100. That means we're using a z-score. If we know this, we use z. So if we're doing a confidence interval, we're going to do the z interval. So z interval. And the population standard deviation, our sample mean, and our sample size, 95% confidence interval, and it gives me my boundaries. So 422.28 to 477.72. I am 95% confident that the true mean score is between 422.28 and 477.72. Based on a random sample of 41 flights, random 41, the average minute of, so mean, average minute of airborne time for an airline was 106 minutes. That's X bar. So N is 41, X bar is 106 with a standard deviation of 5. Is that the population or the sample? It said, based on a random sample, the average minutes of airborne time for an airline was 106 minutes with a standard deviation of 5 minutes. So that was with, that means it's coming from the sample. Can we use a Z interval or are we using a T interval? This would be a T interval. So for this one, I'm trying to speed through this so this video isn't too long. We would go in, 106, 5, 41, still 95%, and calculate. And we get our results. I'm skipping number 6 because I don't believe there's anything like that in the exam. If there ends up being one, let me know. I'm trying to kind of get us through this review a little faster. Now we need to do one with proportions. So a Gallup poll conducted in November 2010 found that 493 out of 1,050 adult Americans believe it is the responsibility of the federal government to make sure all Americans have health care coverage. Obtain a point estimate for the proportion of adult Americans who believe it is the responsibility of the federal government to make sure all Americans have health care coverage. So this is going to be our X over our N. That's 493 out of 1,050. 493 out of 1,050. That's 0.4695. Verify that the requirements for constructing a confidence interval are satisfied. Well, they didn't tell us it's random, but a Gallup poll usually is. So Gallup usually does make it random, so I'm going to assume it's random. We need to check our size. So N times that, so 1,050 times 0.4695. So 1,050 times 0.4695. Oh, that's that 493. That's the number of people that said that they agree with it. Now we need to do the opposite, but guess what? It's definitely going to be bigger. I mean, it's the remainder number of people. It's going to be good. So N times 1 minus P is still going to be good. Construct a 95% confidence interval. Well, since this is a proportion, you're going to look for 1 prop Z interval. Stat tests 1 prop. So be careful, that's a test. That's a hypothesis test. So 1 prop Z interval. X was 493 out of 1,050. And the first one is a 95% confidence interval. And so that's 0.4393 to 0.4997. What happens if I make the percentage for the confidence interval bigger? What happens to our interval? Well, if I'm more confident, my interval actually gets bigger. I mean, if I want to be 100% confident, So this is 0.4299 to 0.5092. So the higher your percentage level, the more spread out it gets. So every time you increase the level of confidence, the width of the interval increases. Okay, now to review hypothesis testing. High levels of dioxin ingested through food and air can cause diabetes, immune disorders, and cancer. The EPA has set a maximum level of dioxin in the blood at 10 parts per trillion. Residents living near an old incinerator known to produce dioxin air pollutants have complained of many health problems. A random sample, of people living within a 10-mile radius of the facility was obtained, and the dioxin levels in the blood of each was measured. Is there evidence to suggest that the mean dioxin level of the blood of these residents is at an unhealthy level? So what is the hypothesis? So the hypothesis, what are they're asking about? They want to know if so the maximum level is at 10 parts per trillion. Technically, that would be less than or equal to 10, because we want to keep it at a maximum. They're wondering, is it at an unhealthy level? An unhealthy level would be that it's greater than 10, so that's my alternative. Now it's saying, what if our sample size is 34? Oh, that's good enough. The mean level for that is 12.365. And the standard deviation is 3.012. Did they give me my population standard deviation? No? Then this is a t-test. So, stat, tests, t-test. Now, what level are we testing? We're testing 10. Our sample is 12.365 with a standard deviation of 3.012. Sample size is 34. Greater than is our alternative. And we got a t-score, that's our test statistic, of 4.578, and a p-value of, now be careful here, it says 3.176, but this e negative 5, that really means 10 to the negative fifth. That really means I have 0.1234, then 3176. That is super, super small. And remember, if p is less than alpha, we are going to reject the null. If I'm rejecting the null, that means there is sufficient evidence that the dioxin levels is greater than 10. So it is unhealthy. It is unhealthy. I'm going to try to get through the rest of these before announcements at the high school, so just bear with me if they pop on. Okay. A noted psychic was tested for ESP. The psychic was presented with 200 cards face down and asked to determine if the card was one of 5 symbols. The psychic was correct in 50 cases. Assume the 200 trials can be treated as a simple random sample. So that's N is 200, and they got it right 50 times. Suppose we wish to see if there's evidence that the psychic is doing better than just guessing, in which case you would be correct 20% of the time. So the null is that he's correct 20% of the time. So 0.20. The alternative, they're saying, is that he's better than that. So better than 20%. That'd be greater than 20%. Better than 20% would be greater. And the 10% significance level means alpha is 0.10. Okay. So for this, we're doing a 1-prop Z test. We're testing 20%, so 0.20. X was 50 out of 200, and we're testing whether it's greater than. And so our z-score, our test statistic, is 1.768, and our p-value is 0.25. Okay. Oh, wait, no, that's not our p-value. What is our p-value? Oh, there it is. I looked at the wrong line, 0.385. Okay. So I'm comparing that to 0.10. Well, it's less. So we're going to reject the null. That means we have sufficient evidence. Sufficient evidence to support that the psychic, I can't spell psychic, is correct more than 20% of the time. I know I'm speeding through this, but I'm really trying to make sure that we're, I get through this. Decide if the researcher made a correct decision, a type 1 error or a type 2 error, given the following situations. Chewing gum shows promise as a new way to lose weight. So a researcher does a study to see if the proportion of people who chew gum and lose weight is greater than 0.50. That means alpha is greater than 0.50. And we're using an alpha of 0.05. So the null would be, well, technically it'd be less than, because it's the opposite. The researcher fails to reject the null hypothesis when in fact the proportion of people who chew gum and lose weight is less than 50%. Oh, they're correct. The researcher rejects the null when in fact the proportion of people who lose weight is less than 50%. They rejected the null when it was true. That's a type 1. The researcher fails to reject the null when in fact the proportion of people who lose weight is greater. So they didn't reject that. So they're accepting it when that's actually true. That's type 2. They reject the null when in fact the proportion of people who chew gum and lose weight is greater than 50. So they rejected the null and accepted this, and that was true. So they were correct. So that's a very, very brief rundown of Module 4. There's a couple of more examples. If you need me to go over those, I'm going to pop up the answers to those. So if you want to kind of try those and then pause the video. Here's the answers to number 11. You can pause the video and just check your answer. And here's the answer to number 12. I'm fixing to run out of time, so that's why I'm going to have to stop the video. But I hope that helps you if you're having trouble on Module 4.